In this video, I'm going to show you how to find the distance on the coordinate plane. Here I have a line segment, and I need to find out how long that line segment is. So what I'm going to do is I'm going to create two rays that match up and create a 90-degree angle. So here's my first one. I'll actually use line segments here instead of rays. And here's my second one. So I've created a 90-degree angle, and from here I just have to count up the lengths of those sides of the legs. So this is 1, 2, 3, 4 for one leg, and 1, 2, 3 units for the other leg. Putting that into the Pythagorean theorem, we find out that the value for this hypotenuse, what we're looking for, will equal 5. Now there's a different way of finding this same value out by using just the coordinates that are given, 4, 1 and 1, 5. What I do is I find the difference between the domains, or the x value, and then I find the difference between the range, or the y values. So here we see we have coordinate 3, 4. From this step, all we need to do is replace A with 3 and B with 4. This works for all types of ways of trying to find the distance on the coordinate plane. So this is a way of doing it without actually graphing it. Now let's take a look at another example. We have a line segment again, and what we need to do is create a right triangle by drawing rays or just line segments where they match up at. Now, whether you draw the triangle so it meets up here or if it meets down here really makes no difference. You're still going to find the same answer for either way. So let's go with the first way I showed you first here, by putting the line segment up here. So now we've got a value, a distance of 1, 2, 3 for one leg, and 1, 2, 3, 4, 5, 6 for the other leg. We'll go ahead and put that into the Pythagorean theorem in order to find out what the distance of our hypotenuse is. Doing it without using the graph paper, we have coordinates 1, 5 and negative 2, 1. The difference between 1 and negative 2 would be 3, and we're using absolute value here because distance is always positive. And the difference between 5 and negative 1 is 6. So just like we did with the graph, 3 squared plus 6 squared equals c squared. 9 plus 36 equals c squared. 9 plus 36 is 45 c squared. Take the square root of that. And c will be approximately 6.7. There are two special right triangles I want to discuss. The first one is a 30, 60, 90-degree triangle. What that means is one angle equals 30 degrees, one angle is 60, and one is 90. Here's our 90-degree. 30 I believe is here, 60 up here. Special thing with 30, 60, 90-degree triangles. The distance of the shortest leg on the triangle is going to be 1/2 the length of the hypotenuse. Or, if you know the distance of the shortest leg of the triangle, the hypotenuse will be twice that length. So C equals 2A. So essentially what that means is for a 30, 60, 90-degree triangle, you can have only one measurement, either the shortest leg A or the hypotenuse C, and determine the other two measurements that you're missing. So let's say A was 3, then C would be 6, and you could use the Pythagorean theorem to determine what B would equal. The other special right triangle I wanted to discuss is the 45, 45, 90 degree triangle. 45 degrees here, 45 degrees there, and there's our 90 degree. The rule for this one is even simpler than the 30, 60, 90 degree triangle. For 45, 45, 90, A equals B. Why does A equal B? Because a 45, 45, 90 is an isosceles triangle. So if these two angles equal each other, that means these two sides equal each other. That's it for the two special right triangles that you need to know about.